Good morning, one and all. Myself, Dr. Ramgopal, working as Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. And today's session is on Introduction to Testing of Hypothesis. And this topic comes under the course Computer-Oriented Statistical Methods. And today I will discuss about the introduction to testing of hypothesis and all the definitions which are required to test a particular hypothesis. And this testing of hypothesis is an interesting and important topic which has many applications in various fields, particularly in industries. For example, to test the quality of product or items manufactured by a company, this testing of hypothesis is used. As an example, a company manufactures televisions and the manufacturer claims that on an average his product works for 10 years. Now we can test the claim of the manufacturer using this testing of hypothesis. Hence, the testing of hypothesis plays an important role in various fields to test the quality of the products manufactured by industries. And next I will discuss the definitions which are required to test a particular hypothesis. Coming to the first part, Introduction to Testing of Hypothesis, a parameter can be estimated from the sample data. So here, before going to discuss the actual topic, I would like to discuss few things like population, parameter, samples, statistics, etc. And all of we know that a population is a set of observations under consideration, and a sample is a non-empty subset of population. Since it is impracticable and uneconomical to study the entire population, we consider a non-empty subset of population and we study that set, and this set is called a sample. For example, population of India is the main population and the population of Maharashtra is a sample of that population. And the process of drawing samples from the population is called sampling. And if we calculate any statistical measurement using a population, that is called a parameter. Whereas if we measure using a sample, then it is called statistic. So a parameter means a statistical measurement calculated using a population. And this parameter can be estimated using the sample data itself. And also, it can be estimated either as a single number or an interval of values. So the parameter can be estimated as a single number, which is called a point estimation. Also, it can be estimated as interval of values. That means we say that the parameter lies between two values. For example, mu lies between, or mu belongs to some a comma b. This is called interval estimation. And there are many problems in which, rather than estimating the value of a parameter, we need to decide whether to accept or reject a statement about the parameter. So that means, instead of finding a fixed value for a parameter, we test the statement whether to accept it or reject it, and this particular statement is called hypothesis, and the decision making procedure about the hypothesis is called testing of hypothesis. For example, the mean of a particular product is 20, mu equal to 20. This is the claim or statement about the parameter. Now, our aim is to test whether this can be accepted or rejected. So, in statistical inference, there are mainly two topics, estimation and testing of hypothesis. In estimation, we estimate the value of a parameter as a single number or in terms of an interval. But in testing of hypothesis, we test the statement whether to accept it or reject it. So that statement is called hypothesis, and this procedure is called testing of hypothesis. Now coming to definitions, a statistical hypothesis is a conjecture about a population parameter. That means an assumption or any statement is called statistical hypothesis. This conjecture may or may not be true. Sometimes the statement may be true or sometimes may not be. And here our work is to test whether it can be accepted or else rejected. And the hypothesis testing is also called significance testing, and these tests a claim about a parameter using evidence. Just now I told you, basing on the sample data, we test the population parameter. So the evidence is based on the sample data. And in hypothesis, there are two types of hypothesis. The first one is null hypothesis and the second alternative hypothesis. The null hypothesis is denoted by H0 and the alternative hypothesis is denoted by H1. A null hypothesis is the actual statement which is to be tested for possible rejection. That means the actual statement which is to be tested is called null hypothesis. For example, a company claims that on an average his product works for 5 years. So, mu equal to 5. This is the null hypothesis H0. H0 is mu equal to 5 years. So, the actual statement which is to be tested for possible rejection. Here, always we try to reject the claim given by the manufacturer. And one more important point is, the null hypothesis should be always in the form of is equal to. So, that means here you see H0 is mu equal to mu naught. We should not use any not less than or greater than or not equal to symbol. Null hypothesis must be always in the form of equal to. And next, coming to alternative hypothesis, term itself is having the word alternative. Alternative means which is not the original. So, any hypothesis other than null hypothesis is called alternative hypothesis and it is denoted by H1. Since the null hypothesis is in the form equal to, any hypothesis other than null hypothesis is an alternative hypothesis. So, there are three types of alternative hypothesis: not equal to type, less than type and greater than type. So, alternative hypotheses are of three types: not equal to, less than, greater than. As an example, here you can see this. For example, mu is not equal to mu naught or mu is greater than mu naught and mu is less than mu naught. And again here there are two different things, two-tailed and one-tailed test that we will discuss later. So, this not equal to case comes under two-tailed alternative and greater than type comes under right one-tailed and less than comes under left one-tailed. So, simply the actual statement which is to be tested for possible rejection, that is called null hypothesis and it is denoted by H0. And alternative hypothesis is any hypothesis other than null hypothesis. So, since null hypothesis is of the form equal to, alternative hypothesis will be of in three different forms and we consider any one of these forms. For example, if mu is greater than mu naught, it cannot be less than mu naught. You cannot consider both simultaneously. So, any of these three forms comes under alternative hypothesis. As an example, let us consider the null hypothesis H0 is mu equal to 1200 hours. For example, a company manufactures tube lights and the manufacturer gave the claim that on an average his product works for 1200 hours. Now, we have to check whether this statement can be accepted or rejected, and then we test this null hypothesis against the alternative hypothesis H1 such that mu is not equal to 1200. This is one of the problems, or sometimes mu less than 1200. The mean lifetime of tube lights is less than 1200 hours. In general, since this is the claim given by the manufacturer, here we always try to reject the manufacturer's claim. So, hence To prove that the given statement is wrong, we have to show that the mean lifetime is 1200 hours. So, it is a less than type problem. For example, if the manufacturer claims that on an average it works for 1200 hours, and if we prove that the mean lifetime is more than 1200 hours, it does not reject the actual statement. It is not the contradiction to the actual statement. So, we have to consider the alternative hypothesis in such a way that we should reject the null hypothesis. And here there is one more point. If we are accepting the null hypothesis, means we have to reject the null alternative hypothesis. For example, if we accept the null hypothesis that mu is 1200 hours, then we have to reject that mu less than 1200 is wrong. Or else, if we are rejecting the null hypothesis, that itself implies we have to accept the alternative hypothesis. So, if the mean lifetime is not 1200 hours, then we have to accept that mean lifetime is less than 1200 hours, hence the manufacturer's claim is wrong. That is the final decision. So, null hypothesis and alternative hypothesis both are in opposite direction. We always test the alternative hypothesis against the null hypothesis, or we test the null hypothesis against the alternative hypothesis. And next, coming to the next topic, types of errors. So, here we are using the word error. Why we get this error? Here, in testing of hypothesis, a parameter of a population is tested using the sample data. That means, to test the entire population, we are considering a small sample or a sample, and using the sample data, we are taking the final decision about the population parameter. So, obviously, this procedure will be associated with some error, as we are not considering all the values of the population. As I told you before, it is not practicable or economically not possible to study the entire population. We consider a sample from that population. And now what we are doing, basing on the sample data, we are taking the decision about entire population. So, obviously, there may exist some errors. As an example, let us suppose on a rainy day, a man going to office is in a dilemma whether to take his umbrella or not. Again, I repeat, on a rainy day, a man going to office is in a dilemma whether he take his umbrella or not. Now, he has to take the final decision, and there are 4 possibilities are there. For example, he went out with umbrella and there was a heavy rain. Now, is the decision good or not? He went with umbrella and on that day there was a heavy rain. So, a good decision. For example, he went without umbrella and there was no rain. So, again good decision. And there are 2 more possibilities. One is, he went without umbrella and there was a rain. So, a bad decision. Similarly, he went with umbrella and there was no rain. Again, a bad decision. So, in procedure of testing of hypothesis, the error comes in the last 2 cases. And as the hypothesis is tested basing on the sample data, in test of hypothesis, every test is associated with some amount of risk, which is called error. And there are 2 types of errors, type 1 error and type 2 error. And we can define these type 1 and type 2 errors similar to the example given before. Now, you see this table. Here 4 different things are there. H naught is true, H naught is false. H naught means the null hypothesis, is true, null hypothesis is false. Reject H naught, do not reject H naught, that means accept H naught. Now for example, H naught is true, but we are rejecting it. Even though H naught is true, we are rejecting it. So type 1 error exists. H naught is false and we are rejecting. Yeah, it's a good decision. Understand? Similarly, H naught is true, but H naught is true and we are not rejecting it. So again a good decision. H naught is true and we are accepting it. So it's a good decision. Next, H naught is false even though we are not rejecting it. H naught is false and we are accepting H naught. So type 2 error exists. So how we can define these two errors? Type 1 error, the type 1 error involves rejection of H naught even though it is true and should be accepted. Actually H naught is true but we are rejecting it. So type 1 error involves rejection of H naught even though it is true and should be accepted. And type 2 error involves acceptance of H naught even though it is false and should be rejected. As H naught is false, we should reject it, but we are accepting it. So in this case type 2 error exists. And there are some more important points related to this topic. The probability of type 1 error is denoted by alpha and the probability of type 2 error is denoted by beta. So alpha is the probability of type 1 error and beta is the probability of type 2 error. And type 1 error is called producer's risk. Once again we will go back. You see, type 1 error exists when we reject H naught even though it is true. That means the product is good, but we are rejecting it. So type 1 error is called producer's risk or manufacturer's risk. And type 2 error is called consumer's risk. And next definition, so consumer's risk. So why it is consumer's risk? As even though H naught is false, we are accepting it. That means the product is not good, but we are accepting it. So in that case, type 2 error exists, hence it is called consumer's risk. And next definition is level of significance. And level of significance is the probability of committing type 1 error. As the probability of type 1 error is alpha, level of significance is also denoted by alpha. So the probability of committing type 1 error is called level of significance. Next definition is critical region. Critical region is the region in which we reject the null hypothesis. So it is the region in which null hypothesis is rejected. So that means here in the process of testing of hypothesis, it follows a particular probability distribution. For example, a normal distribution. Then at some particular region, for example here, in this region, let us suppose we are rejecting H naught, reject H naught. So this region is called critical region, the region in which the null hypothesis is rejected. And level of significance is the probability of committing type 1 error and denoted by alpha. In general, alpha values, the most general values for alpha are 5% and 1% level of significance. Next, types of tests. So basing on the alternative hypothesis, the tests are divided into two types. Alternative hypothesis. So once again, the null hypothesis will be in the form equal to, and alternative hypothesis is not equal to or less than or greater than. There are three types, less than or greater than. So depending on this alternative hypothesis, the tests are divided into two types. One is two-tailed test and one-tailed test. Again in one-tailed test, there are two types, left one-tailed and right one-tailed. Now, how we divide these tests, that we will see now. Two-tailed test. If the alternative hypothesis is of not equal to type, then critical region lies on both tails of the distribution. That means both side tails of the probability distribution. If the alternative hypothesis is of not equal to type, then the critical region lies on both tails of the probability distribution, and critical region of area alpha by 2 lies on left side and alpha by 2 lies on right side. For example, this region is alpha by 2 and this is alpha by 2, and total is alpha. And what is critical region? The region in which we reject null hypothesis. If the alternative hypothesis is of not equal to type, then this critical region lies on both side tails of the probability distribution. So, alpha by 2 area lies on left side, alpha by 2 area lies on right side. Now, in this graph, you can see alternative hypothesis is not equal to type, and values supporting the null hypothesis occur in the green region. That means, in this region, the values are supporting null hypothesis. So, accept H naught in this region, whereas values supporting the alternative hypothesis occur in the red region. In the red region, we are accepting alternative hypothesis. What does it mean? If we are accepting alternative hypothesis, that means we are rejecting H naught. So, reject H naught in this region, red color region. Similarly, here also reject H naught. So, the region in which we reject the null hypothesis is called critical region, and in not equal to type problems, this critical region lies on both side tails of the distribution. Alpha by 2 lies on left side, alpha by 2 lies on right side. In this graph, this green color region is the acceptance region of H naught, whereas the red color region is the rejection region of H naught. So, we are rejecting H naught here. This test is called two-tail test, since the critical region lies on both side tails. Coming to the next, one-tail test. Again, in one-tail test, we have left one-tail test and right one-tail test. The left one-tail test, if the alternative hypothesis is of less than type, if the alternative hypothesis is of less than type, then the critical region of area alpha lies on left side tail of the distribution. Here you can see the red color region in which we reject H naught. So, this is the critical region, and remaining green color, in that region we can accept null hypothesis, but in the red color region we are rejecting null hypothesis. So, that is why that region is called critical region, and this critical region lies on left side, since the alternative hypothesis is of less than type. And a similar explanation for right one-tail test also. If the alternative hypothesis is of greater than type, then the critical region lies on right side tail of the distribution. You can see here in the graph. And again, a critical region of area alpha lies on right side, and that is the red color region in which we are rejecting H naught. Whereas, in the remaining region green, yes, we can accept H naught in the green color region. So, in two-tail test, the critical region lies on both side tails of the distribution. In left one-tail test, the critical region lies on left side, and in right one-tail test, the critical region lies on right side tail of the distribution. And how can we decide whether the test is one-tailed or two-tailed? That depends on alternative hypothesis. If alternative hypothesis is not equal to type, it comes under two-tail test and the critical region lies on both sides. If the alternative hypothesis is less than type, then the critical region lies on left side and the test is called left one-tail test. If the alternative hypothesis is of greater than type, then the critical region lies on right side tail of the distribution, and hence this test is called right one-tail test. And summary of today's session. In the present session, we discussed the introduction to testing of hypothesis and all the definitions required for testing a given hypothesis. Particularly, what is a hypothesis, null hypothesis, alternative hypothesis, level of significance, critical region, and different types of tests like one-tailed and two-tailed tests. And we in the next class, we discuss the steps involved in this procedure of testing of hypothesis. And to know the procedure of testing of hypothesis, we need all these basic definitions. That's why we discussed in the today's session. And in the next session, I will explain how a given hypothesis is to be tested. Thank you very much.